So I'm just giving you to the example to solve with the help of Gauss-Jordan method. We have the system equation. I just change the variables. Instead of x, y, and z, I'm taking x1, x2, and x3. Because in this way we have free. We can take 100 variables. But there x, y, z, we are bounded. So I have this equation, 3 unknowns. We get x1 plus x2 plus 2x3 is equal to 8. Minus x1 minus 2x2 plus 3x3 equal to 1. 3x1 minus 7x2 plus 4x3 equal to 10. Always we write our equation in the augmented matrix form. So my augmented matrix form for this one, we can just write augmented matrix form is that we write the data. This here is 1, 1, 2, and 8. We get minus 1, minus 2, 3, and 1. We get here 3, minus 7, 4, and 10. So in our method of Gauss-Jordan method, we want to reduce this matrix, augmented matrix to this form. Bring here 1, making this one 0, this one 0. So we have a 1 here, 1 to make this one 0, this one 0. It means we add these two. And then to make this one 0, multiply minus 3 and add to this one. So we just add these two. We can just see it here. Our row 1 is not changing. So our row 1 is 1, 1, 2, and 8. Our row 2, we are adding R1, R2. We get here 0. We get here minus 1. And then we get here 5. We get here 9. Now here next is we multiply our equation 1 by 3 and we add to that one. So multiplying equation 1 by minus 3, not 1, 3, minus 3. We get here minus 3, we get here minus 3, we get here minus 6. Multiply minus 3, we get here minus 24. And our R3 is 3, minus 7, we get here 4, and we get here 10. We add this one, we get here 0. Get minus 10, we get here 2, we get here minus 14. This is my new R3. So I can write this one here. We get here 0, we get here minus 10, we get here minus 2, and we get here minus 14. So next step is that we want to bring here 1, and this here is minus 1. So here we just multiply by 1 to make it 1, multiply by R2 by, we get here the first operation. We multiply R2 by minus 1. And then we want to make this one 0. So we add these two. So we get here R2 plus R1. Then we want to bring here 10. So multiply here this one by 10 minus 10. 10 R2 plus R3. So we get the new matrix. So I just write it here. So the matrix I'm going to get by these row operations, the new one is here. We're taking this our row 1 as an operation, multiply minus 1. So you get here 0, get here 1, get here minus 5, and get here minus 9. Even I can write here the operation I've done. I multiply this by minus 1. So I want to take this one R1 plus R2. We get here 1. We get here 0, we get here 7, and we get here 14. Check it again. 1 plus 0 is 0, minus 1 plus 1 is 0, 1 plus 0 is 1, and 5 plus 2 is 7, 9 plus 8 is 17. So we get here 9 plus 8 is 17. Then we multiply this by minus 10. I get here 0, I get here 10, I get here 50, minus 50, and I get here minus 90. Multiplying my row and then add my row 3. So this here is 0, we get here 10, we get here minus 2, we get here minus 14, we add it, we get here 0, and we get this one equal to 0, we get here minus 52, and get here 104. We make the here and other operation, we multiply this row by minus 1 over 52. When multiply by 1 upon 52, I'll get here 0, 0, 1, and 2. So I write here, instead of this one, the last one is 0, 0, 1, and 2. Again, I just explained you. To make this one 0, I multiply by minus 10 add to this one. I get here 0, 0, minus 52, and minus 104. I want to bring here 1, because here must be this one here. I have seen this is 0, 0, 1. I want to bring here 1. I can see, I can immediately multiply minus 52. I get 0, 0, 1, and we get 2. So this is my new matrix which you get. Now what's left? Left is that this must be 0 and this must be 0. So we make the row operations to make them 0, and we are very near to our final solution. Just we take one more step. And step is, operation will be, we'll multiply here by 5 and add to this one. So this will be minus 5 R3 plus R2. That gives me new R2. To make this one 0, multiply minus. Here is multiply 5, not minus 5. Then multiply minus 7, R3 plus R1. So we can just see how the things are changing. First I take this row operation, multiply minus 7, and add to that one. This will be here 0, 0. We get here minus 7, and we get here minus 14. This multiply by 7 to R. The first row is 1, 0, and then get here 7, and get 17. Add it, we get here 1, 0, 0, and 3. So I can write my first row of the new matrix by making the row operation. I'll get here, this is 1, 0, 0, and we get here 3. This is my new row 1. Row 2 is not changing. No, row 3 is not changing. We get 0, 0, 1, and 2. So for row 2, multiply by 5 and add to this one. We get here 0, 0, we get here 5, we get here 10. And my second row is 0, 1, minus 5, minus 9. We add it, get 0, 1, 0, and 1. So I can write this as 0, 1, 0, and 1. So this is my one-step method. Make the elimination and get the result. So you can write here my variables are x1, x2, and x3. What's my x1? My x1 is equal to 3. My x2 is equal to 1. My x3 is equal to is my solution of the system of linear equations. So we can solve the method, this question with the help of the method. We say Gauss elimination method. And as I said you, this is one-step method. There is no two steps like Gauss elimination. This method is one-step method. Just we make the elimination, and we try to reduce our matrix, our argument matrix in the form that we get here 1, get here 1, and get here 1, and above the 1 and below the 1, the values are 0, and we can say that this is our solution.